Okay, hello everybody. Welcome to the Bradford Cloud User Group October virtual event. It's good to be back after a short break last month. Just wanna provide a couple of advance warnings. I've had connectivity issues all day, so if I go off, hopefully Shabazz or Saj will handle it. Secondly, my voice is going, so if it feels like I've gone on mute, I haven't. My voice has just gone. And I want to make an announcement. We have a recently awarded, well-deserved Microsoft MVP within the Bradford Cloud User Group. Mr. Shabazz Dar, well done. If you want to ask him any questions on that towards the end, towards the networking, please feel free to do so. I don't want to put him on the spot because he wasn't actually prepared. He's a bit shocked.
I won't kill you after this.
All right, okay. Yeah, this is the Bradford Cloud User Group, and what we aim to do every month is bring on a new speaker. We originally did have the first time speaker, Laiba Zahoor, lined up for the first session. She's having some issues at the moment with connectivity, so we're hoping to move on to our second speaker first. But let me introduce Laiba Zahoor first. She's traveled virtually from Pakistan, and she wants to share her cloud native journey, the struggles she went through, and where she is today, and kind of lessons learned. Her Twitter handle, if you want to follow her, is on screen, and provide some support and stuff in terms of, yeah, she is doing really well in the technical community. And as usual, we have a Q&A after every session. You're free to unmute, or you can type in chat. And we will then relay that question onto the speaker. And second session, which is now going to be first, I believe, and Laiba will go in second due to connectivity issues, is Microsoft Azure MVP Wesley Haakman, and I know I pronounced that properly because I did some research. He'll be presenting a session on getting started with Azure IoT and creating your first win. Wesley's from the Netherlands, works for a company called Intercept. That's his Twitter handle there if you want to follow Wesley. And then we will have some more Q&As. And again, if you want to post your comments in chat, please feel free to do so, or you can unmute yourself and ask the question yourself. So yeah, let's get started with session number 1 with Wesley, and then hopefully session number 2 with Laiba if she comes back and out of her connectivity issues. So over to you, Wesley. Thank you.
All right, thank you. And that pronunciation was spot on.
Cheers,
that was great. It was very good, very good. All right, let me share my screen. Hopefully I'm sharing the right one. There we go. Teams up here, present view up there. We should be good. All right, can you all see it? Well, you can all hear me. So
yep, can see
all
you.
Right.
Yeah.
So my goal today is pretty much share how I got started with IoT, and it's a bit of a different approach, and we're going to do some live coding or copy and pasting and get this stuff up and running, because I just want to share a different way on how you can go about getting started with the technology. And this time I'm going to focus on IoT, and we'll put some IoT Hub in there. Well, I don't really need to introduce myself anymore because you just did a great job. I'm Wesley Haakman, so that was a good pronunciation. I work as a lead Azure architect at Intercept. Yeah, Microsoft Azure MVP. Like what was just mentioned, if you got questions, feel free to unmute yourself, put it in chat. I've got the chat open, so if you feel more comfortable putting your question in chat, I'll respond to that. And well, let's just get into it. So it's really about how do you learn? And one of the things that you read a lot about is people go like learn by doing. And what I do every day is jump on calls with people and just have some kind of sparring session. And 9 out of 10 times, it's like people ask me a question and I have no idea how that technology works. We just grab the dogs, put something together and just figure it out. And it's not so much learn by doing. I mean, if you go to Microsoft Learn, it's great, it's brilliant, but I'm like I always pick the path of least resistance, and it's human nature. A lot of people do. And I open up Microsoft Learn and I start looking at the samples, and then they tell me do this, do that, and I'm basically just, copy and pasting from one window to another in Microsoft Learn, and then at the end, I read about all the technologies. I think I understand the conceptual part of it, but do I really know how it works, and do I really now have the knowledge to get started with building my first little project? So the question, how do you learn? And I think that is not learn by doing. Obviously you have to do stuff, but learn by challenging yourself. And that's it. It's just grab a pet project and start building it. And what we're going to do today is look at some IoT samples and just keep building on top of that. Obviously it's good to do the Microsoft Learn stuff, read the docs, but you don't need to be the expert in programming Python or .NET or anything. You can get started pretty quickly. And the process really is, start reading the documentation. And I don't know how you all read the documentation, but I just skim through it, like, oh, that's interesting. And then I try. That's how it works in IT, to my opinion. I try and then I fail, and then I start reading the documentation thoroughly. So that's usually how it goes. And what I learned is don't go with the default samples and think you know it. If you're learning for a certification, like maybe you want to do the IoT developer, yeah, obviously you can download the IoT Central samples, you can download the samples from GitHub, execute them, but do you really understand what's happening? And I thought, well, not really. Let's just think of a challenge and go from there. And then if you work with IoT, then yes, you can do the local simulation samples that you can just run on your laptop. But I like to just, get a Raspberry Pi, pretty much grab any sensor I've got. I spent about $20 on this little box, and it's got about 20 different sensors, lots of cables. And to be honest, about half of these sensors, I have no clue what they're doing. But I just started attaching them and figure it out. What did help me, it's got a picture of it later, is got a GPIO extension board, because I am not the soldering or electronic resistance specialist. I just went the easy way, bought the right stuff. It's not that expensive, and then, go from there. And then really what you need is just a lot of skill in Googling. You just need to try and find that. And what I want to do today is start with a sample from scratch and see if we can, hook up some IoT stuff, build it, see if we can get it running, and see if we can be successful and have your first win, if you will. And what's really important here is it's not about code quality. You don't have to be. When I started with this about a year ago, I had really no experience on programming for devices using Python. I had no clue. I mean, I had some experience with Python in the past, but not enough to build something from scratch. But I could read it. So I just started figuring out what is it really doing and go from there. So let's just try that. And the demo I'm going to do, it can be a lot of trial and erroring. We're just going to do it live. Obviously, I've got some code that works, but let's see if we can just get it up and running by copy pasting, changing some code, and see if we can get it working. So this is actually my setup. That's really just here on my desk, like below me. I can do my camera a little bit, and you can see that it's up there. And what it is it's a breadboard. It's got the GPIO extension board. That's the red thing over here. And that just helps me, telling me, hey, if I plug stuff in, if you get the sensor, you can see the sensor here. That's a motion detection sensor. And it's a PIR sensor. And what it does is it does motion detection. So the more motion you see, the more data it will send to the breadboard, and that eventually ends up in the Raspberry Pi that's next to it. But what that GPIO extension board does is tell me, if I go to an example on the internet and it tells me, hey, you have to put that cable from that sensor into the ground or into the 5-volt thing or into the GPIO pin, this will just help me pick the right pin, so I don't need any knowledge with electrical engineering, I can just get started with that. And if you translate that to a more practical thing, let's say you're going to work at a company that does IoT. Obviously, they've got lots of standards and they will help you and train you and all that stuff. But getting started is just this, get your very first sample, get the confidence in writing that code, copy and pasting, get confidence in getting that up and running, and then you build from there. And that is, I just named it, learn by challenging yourself. But I think that is the true meaning of learn by doing, just to learn from it. Fail a lot. You can spend the whole evening doing this and then just move on. So the goal, what we want to do today is we're going to do baby steps. So we're going to start small and then change some stuff together. And what we want is we want to have the Raspberry Pi talk to IoT Hub in Azure. We want to have a sensor up and running, which is going to be our motion detection sensor, and connected running on Raspberry Pi, and see if we can gather some data from that. And then we want to send that sensor data to IoT Hub. And if we're not running out of time and we're lucky, let's build a provision and Azure function and see if we can process those messages. And I've got a slide here. I'll share the slides with y'all, but this is just the samples that I use. This is all I needed to get started building this. And let's just start doing that. So what I've got here, I'll make it a bit bigger actually. I've got Visual Studio Code. I've got it connected to the Raspberry Pi. And that means that I can just browse the directories on the Raspberry Pi. You can see that I already tried some stuff that's working and created a new directory. And if we go back to our goals, the first goal is, can we connect a Raspberry Pi to IoT Hub? So we're not even dealing with the sensor yet. Just want to see, hey, can we grab some code and then can we connect that to IoT Hub? And one of the examples I've got, and we're just going to do exactly that, is I went to the Azure samples and got the Azure IoT samples in Python. So before we go copy and pasting that stuff, if we look at my Azure subscription, I've got an IoT Hub running here. I provisioned that before the session because, well, in a live demo, you don't want to have to put a provisioning. Usually it goes really fast, but when you're doing a live demo, then stuff usually fails. So we'll see if that works with the function later on. So I've got the IoT Hub, and I've got the sample code. And if we just look at what this is doing, and when I first got started, I had no idea what this is doing. I mean, I do understand connection string. Obviously, it's a connection string, and it's getting an environment variable, which means that if I run this, I have to set the environment variable. However, I just want to run this locally on my Raspberry Pi, and what you can see is that what this is doing, and when you run it, you'll figure out what it's doing. But after a time, I learned what it was doing. It's just going to generate random numbers for temperature. It creates a client to connect to IoT. It's using the Azure IoT libraries for Python. And it's just going to loop through the whole thing, and then every couple of seconds, it will create a random temperature and send that using this client, that message to IoT Hub. All the other stuff, no idea. Back then, I had no idea. So what we're going to do is we're just going to copy and paste this thing. We're just going to copy and paste this, and then we're going to go back to our Raspberry Pi, and we're going to create a new file and just see what's happening. And we'll call this IoT Hub 1.py. Now, what we're going to do is copy and paste it, and this is, maybe this will run. What we need to do is, I mean, if we're going to save this, first what we want to do is, and that requires, you don't have to do it, you can execute it with a Python and on the Python script you want to run, but what we're going to do is actually make sure we can just execute the file, which means we have to, what we call hash bang in Linux. So if we do /bin/python 3, that's what a Python executable is. And if we would run this right now, and this is how I learned by trial and erroring, we're going to now open up our code, our terminal, and we're connected to Raspberry Pi. We can see IoT Hub 1. We're going to make it executable. And we can now do IoT Hub 1, and it's going to go, hey, it fails. And why would it fail? Because the connection string must be of type string. Now you can start Googling on, all right, I'm not experienced with Linux, maybe you don't have that experience. How do I set the environment variable? We can also just go back to the code and think, all right, apparently a connection string needs to go here, and it needs to be of type string, because that's what we saw in the error. So we're going to open up that IoT Hub thing. Let me see where I got that. Here we got the code, we got the IoT Hub, and let's just browse a bit through it. Devices, configuration, shared access policies, sounds like something. Maybe not. Settings, no, what we need is a device. But if we go to devices, because what we need to do, if you use IoT Hub, you want to identify your device. So normally you would set up all kinds of complicated certificates for authentication and maybe do some automatic provisioning of devices, but that's not what we're going to do. We want to take it easy. We want to create our first win. We just want to get it up and running. So we're just going to go with a simple key. First, what we need to do is make sure that we have a device in IoT Hub that can identify with our local device. So it's going to be our device representation in IoT Hub of the device we're going to run locally. So we're going to call this Bradford UG device 1. And we're going to use the symmetric key. You can do the certificates. That's the best practice in terms of security, but we're going to do the symmetric key. I'm going to save that. And you can see I've now created a device. And if I click on that device, I can see that we got no secrets here, so I'll make it all visible. I've got a primary connection string here. So that sounds like something that we can use, right? That sounds like something we can use for our code. So we're going to copy that, and then we're going to open up our code again. And we're just going to remove this. We're just going to go, all right, connection string needs to be of type string, which we do with the quotes. We're just going to paste it in there. And then that's the only change we made. And under that, it still does the temperature sensor stuff. It's very cool. We're going to open up a terminal again. Let's clear it and do that thing again. Now it's connecting to IoT Hub. We got the connection string in, and now we're actually sending data to the IoT Hub, and it's not doing anything with it, just storing it, but we've got data. Now, to see if that's working, you can build all kinds of solutions to read out the built-in endpoints or sync your message into other complicated event hubs or databases, whatever. But we want to understand how this thing works. So what you can do is use the Azure IoT Explorer. And the Azure IoT Explorer is a tool. You can download it from the Microsoft Docs website. And what it will do is allow you to connect to your IoT Hub and read the built-in endpoints, which is an event hub endpoint. And let's just click a few devices and see if we can identify our device. And we can see that our device is here, the Bradford UG device 1. And if we click on that, we've got the option to click telemetry. So we're now actually connected to the IoT Hub in Azure. We're going to get started and see if we can gather some telemetry. It's going to take a couple of seconds, and we can see that in the background. If we scroll a bit, we can see that it's still sending stuff. So it might take a couple of seconds, but eventually it should show up and show our messages. I don't think I've got too much patience, but there we go. There we go. We got the messages. So we can see that the messages being sent here in the back are ending up in our IoT Hub. So that is already a very first good sample. We modified the sample slightly because we just added the connection string, and we got something that's connecting to IoT Hub, even though this is still simulating a sensor, it's simulating data. But we already got a device. We got the Raspberry Pi connected to IoT Hub through the Python script that we downloaded. So that's pretty cool. And this can run for a long time. We're not going to do that. We're not going to wait for all that. Just going to hit stop. And we're going to cancel this. So that is the first thing. And then What's next? We now have the sample connecting to IoT Hub, but we want to work with a sensor. We want to work with that motion detection sensor that's on my desk here. So then we just start Googling again. And what I ended up with was with the Pi Hub, really good website. And what this is telling me is, so this is the actual sensor that I'm using. And if we just scroll down, it's going to tell me previous tutorials, peer sensors. All right, passive infrared, didn't know that, sounds good. So it does infrared motion detection. And what I did is set the sensitivity really, really high. That works well for demos, but in practice, you probably don't want to do that. You could do the same thing with a temperature sensor, with a camera, but anything goes as long as you connect it to the IoT Hub. So they're explaining me how to connect it. This is directly to the breadboard. I use that extension board, that red thing on my breadboard, because that makes it easier for me, because I don't want to understand about all the electricity stuff. And it's going to tell me, all right, I've got a library like GPIO as a library. I need time. Apparently, I need that library. And I'm going to set the mode to BCM, and GPIO.BCM is a way to identify which GPIO, my breadboard, which number is corresponding with my sensor. And then I get to the interesting part. Apparently, I can just check if the GPIO is generating input. And if that is true, it's detecting motion. And that is, the way that works is really, the sensors are really sensitive, and the Raspberry Pi and the GPIOs are really sensitive. But the more electricity is generating, basically, that means motion detected. So it's got a static, and then if it jumps, means motion detected. So the thing is, can we work with this? And we could try to include this into the sample we just had, but maybe we just want to check if we can we get this? Can we get this to work? And we're just going to try that. We're going to open up Visual Studio Code again, and we're going to create a new file. And we're going to call that pair1.py. Then we're going to paste that in. So we got some code here. And the first thing we need to do is add that hashtag again, so we can make it executable, so we can tell the system upon execution, look at that executable, and that will help you. Then what we're seeing here is the quotes. That's not going to work. So normally you would change it to that. Believe it or not, for me, that was trial and error as well to get this up and running. And we're going to do that here as well. And then over there, because now everything will fail. And then the quit statement as well, whatever they print. So got that. Now this is saying something other than an amount does not match previous intent. So then we're going to go back to the page. What does the page tell me? So if print time sleep indentation is the same thing as the if statement. So what first we want to do is just move this back a bit. And it means now it's really nice within no while true loop. Now let's try it. Let's try if we can. Let's see what happens when we execute that. Py. So it's just ready, and it's on the desk and it's really sensitive. So it's actually detecting motion right now. And it's even because I got all my LED lighting here. So whenever you move it, it's going to detect motion. So that works. So we're now interacting with, with our local sensor. And if I go back to this, I can even change. Let's do actually connect to 2 pins, but let's do 23, because that's the actual pin it's connecting to, not just sending a message. Now it will probably just start spamming some stuff. Yeah, but now we got this right. We've got our motion sensor connected. We can, we know that it works. But what if we want to send those messages, that motion detection message? What if we want to send this to Azure? What if we just want to, automate the thing and send it to IoT Hub and then work with that? That means that we've now got two scripts. We've got the sample and we've got the pair sensor. So going back to the code, we've now got the IoT Hub. We've got IoT Hub 1, which has got the connection string, which lets us send messages to the IoT Hub. And we've got the pair motion sensor. That's basically just reading the sensor. So if there's motion detected, then there's motion detected. So we want to stitch this together, right? We want to make sure that we can read from the sensor and we can send it to Azure using all this. Now, we could just simply try copy and paste all that stuff in, but that's not simply going to work. First, what we want to do is, this is how I learned it. All right, so obviously I need the GPIO library. So I'm going to create a new file. Let's create a new file, and let's do IoT Hub2.py. And first of all, let's just copy this whole thing in, because the majority of the code that we need is going to be in this sample. We're going to pass this in. We pretty much got the same file, and now let's see. This doesn't have the GPIO library, so let's copy that in. IoT Hub, let's do that. And connection string is going to be the same. First thing we're going to do though, oh no, we're going to do that later. I was thinking let's clean up the queue so we don't see the old messages, but that's fine for now. We got the connection string, we need that. And then if we look at this example, we need to set the mode to BCM. We need to identify the pin, and we need to set up the GPIO.in. So we're going to do that. There we go. So now we configure the script to read from the GPIO pin, or at least identify it. The next thing we need is, well, we want to do this. If there's GPIO input on pin number 23, we want to print motion detected, or else we just want to sleep and wait for it and do it over again. And then on keyboard interrupt, we want to stop. For my proof of concept code, I really don't care about the GPIO cleanup and the print. Well, let's see what we got here. Let's first see what we don't need. What we don't need is the temperature and humidity. We really don't want to send that sample code, and we're just going to go from top to bottom, right? All right, we got a message text, and this says temperature, but we want to do like motion detected, and then we're going to do motion detected. Detected. That's the worst thing of live sessions. You make typos. And then we need, we opened it, 1, 2, so we got 1, 2, so that should do it, just to format our JSON object. So we got that. Where did I copy? Oh, I did that in the wrong file. See, this is great. We're going to do that here in this thing. This is our new file. So we got that, and we got the connection string. We don't need the temperature. We don't need this. We just changed that. So we're just going to delete that. We put a little comment in there, like JSON formatting for message. In on Bradford or on the GPIO, like standard really. And we got the connection string, and we got this. We got the run telemetry sample, we've got main, we've got all that. Oh, it's fine. So we don't need this. We don't need temperature, humidity, we don't want that. We want to do the message text formatted, because we do need that. We do want to format the text, right? And that's going to be something like motion detected is motion detected. We're going to remove the humidity because we don't need that. This is going to be the same. That works. And what we want to do is if we want to send the same message, we don't need the temperature thing here. And then we don't need, well, we still want to send a message. We might want to have that sleep. But we also want to check, is there input from the GPIO pin, right? So if GPIO input is true, and then we just want to put everything in there. So what I'm going to do is I'm going to copy paste the demo file I've got, and then I'll talk you through it. So because I don't want to make too many typos. So what we have here is still the same file, connection string, GPIO text, and then what I copy pasted in here was this while true, and then the if else statement. Also renamed this one, but while true, if the GPIO input peer pin, which is the same, basically I'm doing the same thing here. If there's input from the pin, so if the motion detection sensor is detecting motion, do something. And we're doing that here. We're going to set motion detection to true. We've got the message text formatting. We're setting this custom property, motion detector alert is true. Maybe we need that custom property in the future. You don't have to set it. And I'm just going to send the message, and I'm going to use that client that I've got here, create client, which is just using the connection string, returns a client, just like object-oriented programming, but in a Python script. Always baffles me. I'm not a Python expert, but it works. And then it should send a message. So the thing is that we do need to copy and paste that connection string from here. IoT Hub, and we're still copy and pasting. There's not much manual code writing here. So what we're doing now is we've got everything set up. We've got the telemetry sample. I still have it run telemetry sample. It's still called that. Obviously, it doesn't do a sample. It's actually reading from a live object, the peer sensor. But I don't care about that. That's how we started, right? We don't want perfect coding. We just want to get it up and running and go from there. So this is all IoT Hub Quick Start simulated device. So we just leave that. We just leave all that other stuff. I'm just going to save that. And then go in here. We have it. Let's put it on the screen. I'm going to make that executable again. IoT Hub 2.py. And then we're going to execute it. And now it's saying no motion detected until I start touching the thing here on my desk, the little sensor. And then it says, all right, motion detected is true. And now if we go back, we got Explorer here, right? So let's hit start. And I now got it pointing at me and my keyboard, which has got LED lights that changing all over the place, got like colors changing. So it should say that it's seeing motion all the time. So now we're going to wait for this to connect. And what we'll see is that once it loads, that these messages should now be ending up in our IoT Hub. And we're about 30 minutes in. We use the sample and we translated both samples, the sample of the peer sensor to the peer sensor and the sample of IoT Hub with the Python code, and we translated that into something that should be working. So it's receiving events. It's not the quickest, but that's it with live demos. It's never the quickest. But you can see that it is. If it didn't connect to IoT Hub, it would definitely error out here. I'm just going to wait for that. And then in the meanwhile, before we wait for this to pop up, once we get this working, then we got our motion detection data in Azure. Then what is next? What comes after that? And what comes after that? I'm just going to stop this and clear the events and then go from there. After that, what we want to do is, do something with that data. Maybe just connect an Azure function to it, connect a logic app to it, or anything else. And what you need to understand with IoT Hub, and that's very important. Just let's go to this one. If I go to my IoT Hub, you've got something called built-in endpoints. So for your testing stuff and learning stuff, you don't really need to sync everything into Stream Analytics or into a storage account or into a database or anything. No, we've got an Event Hub compatible endpoint. So we've got the endpoint here, SB, and then the access key. So that looks like something that we can work with. And then if we want to use Azure Functions, believe it or not, there is a trigger for Event Hub. So that might be something that we can work with. We're going to check this again. I don't think we're going to wait for this thing. Maybe we should just try to connect this again. It is enabled. That's telemetry. Still in preview, so that's why it might break, I guess. This thing is still sending data. Yeah, it is. Right. In the meanwhile, we can see that if we go to IoT Hub, oh, sorry about that. If we go to the IoT Hub, we can see that it is actually receiving data. So we can confirm that it's working. 737, yeah, that's about right. So it does work, but apparently I just want to get it up and working, live demo. So let's do IoT Explorer. Let's connect to it. It'll take a couple of seconds and I'll put it on the screen. See if it's going to work now, or else we're just going to stop working on an Azure function. In the meanwhile, this thing is still sending a little data. What we do want to check, we want to double check is IoT Hub, Bradford UG device 1, and that is also matching up with the device we've got here. Yeah, looks good. So that should be working. Let's open up this again. I don't think I want to wait for that. Let's just leave that for now. Maybe it'll pop up later. Just put some different screen. In the meanwhile, what we want to do, because we could see in the Azure portal that it's actually receiving messages. Let's go and see if we can use an Azure function and if we can read those messages, if we can see what's happening with those messages. And what we need for that is an Azure function. So what we got here, let's just do func new, and then you still don't need to have that much of .NET knowledge for this. We're just going to open this func new and see what it comes up with. It's going to say, all right, I've got Q trigger, HTTP trigger, I've got an Event Hub trigger, and that matches with what I've seen here. What I've seen here was Event Hub compatible endpoint. Compatible, so that sounds like something. You've got the IoT Hub trigger, don't bother with that. I prefer the Event Hub trigger. We'll give this a name. We're going to call this function UG01. It's going to create the Azure function. I'm going to wait a little bit and then it should pop up. It's been created. And then we can see that we've got function UG01 here. And if we're going to open that up in your window, we can see that it's scaffolded. Yeah, sure, let's do that. We've got this, and there's not much we need to change to get like the very basic example up and running. What we can do is we need to find the name of our IoT hub, which we got here, which is IoT Hub WH. Let's do that. And then we're going to change that to IoT Hub WH. Did I not put a number in? Well, that's fine. Okay. And then we got a connection, and we're going to call this IoT Hub connection. So that means that we need to have an IoT Hub connection variable, because this variable is going to be passed upon runtime. what we need here is for our local testing, we're going to put in the connection string, and that connection string is going to be this very Event Hub compatible endpoint. It's got the shared access key, everything, again, not for production, but great for testing, getting your solution up and running. We're going to put that there. The IoT connection up and running. And just to show you that the IoT Hub Explorer is working, it's still sending data. What we can see here, motion detected alert true. This is the property that we set. And it's doing that a couple of times now. So we can now verify that our telemetry locally, gathered locally on the Raspberry Pi is being sent to Azure IoT Hub and it's reading that device. So that's working, which is good. I'm just gonna leave that for now, but apparently it took a very long time to connect, but that's fine. I think that's what happens with demos. So for an Azure function, we also need web job storage. So I'm not going to run the local simulator right now. What I'm going to do is go to my Azure Portal, and I've already got something. I got this demo function, but we're just going to use the storage account for that. We're just going to grab a random storage account. We don't care about it. We're just going to do something really ugly. Grab the access key and do show keys. And we're just going to grab that. Again, not something you want to do in production. I'm just going to set this because the function needs storage account, and that should work. So now we've got the IoT Hub connection defined. We've got the Azure Web Job Storage defined. We've got the function configured here. And basically all this will do is just read from the Event Hub queue. It will just retrieve those messages. And we're going to go back to command line because we can run this thing locally. As you can see, the sensor is still running. Sometimes it detects motion, sometimes it doesn't. That's fine. It's just when I'm moving, it detects something. So we still got this. And what we're going to do is function start. So do a function start. See if this thing will start up, or if we made a mistake, or if we broke something. Apparently, it's running. So now this function is looking at the Event Hub queue, and you can see here. Even though the function is running locally, it's still connecting to not this one. It's connected to this one. So here we said, trigger on Event Hub WH. This is the connection string. And normally you would want to pick a specific device, but because we've only got one device and we want to go for that first win, stitching it all together, we just want to grab that information. It's running, apparently it's running, it's checking that Event Hub endpoint. And we're going to check this. We can see that whenever there's motion detected, the function is being executed. So imagine that now you can build some logic. All right, motion detection is true. What if I've got Philips Hue lighting and I can expose that endpoint and I could make my lights flash? We're not going to do that in this demo, but what if I wanted to do that? I now have everything in place to start doing that. Because I just connected my infrared peer sensor locally within a matter of just above 30 minutes to an Azure function by just disregarding all security best practices, but I've got something to work with. The only thing we need to do now is, all right, let's start running that function because this is running locally. I don't want to run that function locally because that doesn't sound like a good idea. So if we open back that function again, I'm just going to go Control P and then deploy to function app. That sounds like a good idea. Obviously, I got the function core tools installed. So I'm going to create a new function app in Azure. Sounds like a good idea. And let's call it Bradford function 01, function app 01. Good. It's going to run on .NET Core 3.1. West Europe sounds like a plan. It's going to create the use, it's going to create the resource group, it's going to create the function app, and then what we want to do after that is publish the function to the function app. However, before we run the function, we're using the local settings here. So what we did was Azure Web Job Storage. This will be propagated by default when you provision an Azure function app, but we need to create the IoT Hub connection app setting. because that's going to be injected upon runtime into this little thing. And still, just like to remind you, we haven't been really writing code. We've just been copy pasting stuff and trial and erroring. And obviously, I prepared this, so I'm not trialing and erroring as much as that, as that you might have to introduce for the first time. But to be honest, I got this up and running the first time I worked with this. I got this up and running within about an afternoon. Instead of the afternoon, just started playing with it. My desk looked like a mess because I was trying all the cool sensors that I didn't understand, and then I figured the motion detection one was pretty cool. The temperature sensor is going to be really cool, but then yeah, I thought everyone's doing temperature, so I want to do something else. So we're going to wait for that to provision. We can go and check if our function, we call it Bradford UG some Bradford function app 01. There we go. So it's still provisioning. We're still good on time, I think. So we're gonna make this happen. Says all right. I'm now restoring it. Let's see what works. That means that the function app should be popping up there any minute now. The function app itself. And then we want to set that connection string. We want to change that app setting and configure it to look at the IoT Hub, because we now got that function running, but it won't look at the IoT Hub yet. We need to inject that variable. So here's my impatient me. There we go, function app. So what I want to do is go to those app settings, configuration, and you can see that the Azure Web Job Storage, it's already there. So what I want to do is do a new application setting, do IoT Hub connection. That's what we called it because I just copy and pasted it. Go to the local settings again and then copy that endpoint. Let's in here. So now we got that. We pretty much got that local settings that we had. We now got that configured here. Hit continue. It's going to restart a little bit. And the big question with function apps, if you deploy them from VS Code, is always, will this work? Because sometimes it just doesn't pop up. We'll see if it shows the function. We're going to be very patient here. It doesn't yet. Even though it built it, it probably didn't push it. So what we're going to do is we're going to do that again and then deploy to function app, this one, and now it should just deploy the code. Yes, let's do that. There we go, building project, blah, 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 doing the restore and then publishing it. Okay. Then once it's done, we should be able to, I mean, the sensor is still running, I think. Yeah, it's still running. Still running. So we move a little bit here, it should, yeah, there we go. The motion still works. So we're waiting for that function to deploy. Now we can attach to it from Visual Studio Code, or we go to the Azure Portal. Really, what you prefer, doesn't really matter. I really like attaching to the log stream locally. However, some people like the Azure Portal way of doing things. I'm not that person, but let's just see, because that's the better example, so you can actually see it's running in Azure. We're going to go to Code and Test. And then click on, what is that going here? Oh, logs, there we go. Open this up. Can we make this bigger? See, now it's running in Azure. And we can see that motion detection is true. And if we start moving again here locally, we can see that now the function is being executed. And now we got a way to build all that other logic just from, it's been 45 minutes and we copy and pasted some stuff into an Azure sample. We played around with the pair sensor. We stitched it together to send messages to IoT Hub. We could connect to the endpoint. We verified that. And now we've got an Azure function being triggered by that Event Hub endpoint on IoT Hub. And it's working. So we're not going to go very much further than this, but now I can just put my .NET skills to the test and build all kinds of stuff in this Azure function and trigger other stuff, or make lights start flashing, or trigger logic apps, send an email. I don't know, maybe I'm very wary of my virtual machines for who knows what kind of reason, but I want to turn off my virtual machines when motion is detected. That'd be quite weird, but just trying to think of an example there. I can now do that from that function app. I now can respond to my peer motion sensor and the things that it's doing. And it's been 45 minutes. And we did it with not too much errors, luckily. But that's how you can, get started with the IoT thing. Just copy paste, play with it, trial and error, figure it out. Then once you fail, start reading some documentation. I mean, I've used the GPO Pi-Hut website. I've used GitHub. I play with function apps. I already have the knowledge of function apps, but really, if we start Googling, I mean, we can just do Azure function apps, event hub, trigger, and well, this is going to be very Dutch, so you probably can make anything of this, but we can just go through this, see how it works. I mean, see, this is the same code. We just learned from this. We can still copy and paste it without knowing anything. So that's the story I wanted to tell today, and hopefully help you get started with a new way of learning and get some experience with IoT, because there is no better thing than plugging in your IoT stuff and then start copy pasting or writing code, because eventually you will get to the writing of code. You will find it interesting if it's your hobby, and then you will build really nice stuff. But this is how you get started, and hopefully I could send that message and share it with you. And that's it. That was my talk for today.
Hi, Wesley. Thank you. Great chat.
Thank you.
Does anybody have any questions? There's no questions in the chat that I can see. We're all too amazed, Wesley, that it all actually worked.
We were just tweeting, mate. You've got a lot of tweets to catch up on. We were saying you were cool as a cucumber with your demos.
Cool as a cucumber. Oh, I do see a lot of tweets there. Yeah. Oh, that's cool.
So Chris is typing, we'll give him a minute. So unfortunately, our second session won't be happening tonight. Live is having some internet connections in Pakistan, so we'll try to reschedule. She is going to record the session, so we will edit that in when we upload Wesley's session to YouTube, so you'll be able to watch it as a recorded session on our YouTube.
Hello everyone, I'm Zoho from Pakistan. I'm doing software engineering from UIIT Rawalpindi, Pakistan, and I have completed my 6 semesters. Moreover, I'm also doing an internship at Cloud Native Islamabad, and I started a challenge of 100 days of Kubernetes. So if you are curious about how I'm trying to fulfilling my challenge of 100 days of Kubernetes, what I have learned till now, so far I wrote my blogs on dev.to, because I know a lot of people love to read instead of watching videos. So as a good human being, I should also take care of them. So I did. So you are good to go to my dev.to account and learn how I started my journey, what I learned till now. But if you don't want to read more to grab knowledge, no worries. I'm always here to help you out and share my knowledge in any form, either in its form of blog or from in YouTube videos. So you are good to go and check my YouTube channel named Explore Technologies, where I uploaded my different videos related whatever I have learned till now about 100 days of Kubernetes. So you can follow, you can subscribe my YouTube channel and see what I have learned till now. And after that, here are my some social accounts where you can reach me. I would love to make connection with you all. So just just catch me on Twitter, on LinkedIn, on GitHub, where you want. So this is all about me, who I am. After knowing about me, next move towards our today's topic, which is cloud native. The word cloud native is not only trying to change my way of thinking, but also trying to change my way of exploring different things. Like if we talk about cloud native, so cloud native is all about speed and agility. It is an approach to build, run, and ship applications that exploit the advantages of cloud computing delivery model. Like how satisfying and life-saving word the cloud native is, isn't it? Yeah, it is. But you know what? About 2 months ago, I don't have any knowledge related to cloud native. Even I never heard about the word cloud native. I don't at that time I didn't know about what is cloud native and all this stuff. But during COVID days, when everyone was isolated and I have nothing to do, I wanted to do something creative and explore something innovative and exciting about technologies. Then I started exploring about different technologies, and after exploring different technologies, the one word, not word, but a group of words stuck into my mind, and that was cloud native. At that time, I stopped there because I wanted to know more about cloud native, like what is cloud native, why everyone is talking about cloud native, and more such type of stuff. Okay, then I started to Google about cloud native, like why we need it, what is cloud native, and all this stuff. But basically, I want to deep dive into cloud native. So for this, I started research. I started searching for people, for community who are already in this field, so they can help me in a better way, because I want some guideline about how to get into cloud native field, and much more stuff like this. Okay, so then one of my friend told me about community who will help me, which is Cloud Native Islamabad. Okay, let me tell you something about Cloud Native Islamabad. Cloud Native Islamabad is the official CNCF made-up group dedicated to build a strong, open, diverse developer community around cloud native platform and technologies in Islamabad. It always shared a valuable content related to cloud native. So you can follow this community on LinkedIn, on Twitter, and don't forget to subscribe its YouTube channel, Cloud Native Islamabad. If you want to know more about Cloud Native, then you should subscribe YouTube channel, Cloud Native Islamabad. And after this, my friend also told me about Sam Sardar, who is a DevOps engineer, a co-founder of Cloud Native Islamabad, and more about a cloud native enthusiast. Yeah, he also recorded a valuable podcast related to cloud native. So you should subscribe his YouTube channel, cloudnative.fm podcast. Okay, you can follow him on LinkedIn, on Twitter, where you want to grab knowledge related to cloud native. Okay, so my friend told me that he will help you to take this initiative, and I was like, okay, let me check. And then I silently started following Sam Sildar and Cloud Native Islamabad on Twitter, on LinkedIn. And after following, I was inspired a lot with their content, And after that, I requested Sam Sodo, I requested him to guide me and provide me a suitable way for how to get into cloud native world. Basically, I asked for an internship. He is so kind and a pure soul. He accepted my request, and I remember at August 2, yeah, at August 2, I joined Cloud Native Islamabad community as an intern, and I gave myself a challenge of 100 days of Kubernetes. Yeah, so at that time, I decided and I promised myself that whatever I will learn, I will share it with others, and I will dedicate my next 100 days to Kubernetes. In my next 100 days, I will learn a lot related to Kubernetes. Okay, that's all about how I started my 100 days of Kubernetes. But after joining Cloud Native Islamabad, I also learned a lot. And I want to share some point tips and tricks with you what I learned from Cloud Native Islamabad. So the first and foremost tip and trick which I learned is whatever you learn from your life, from your experience, from every day in your life, you should share it with others. No worries in what form you can share, either via blog post, via YouTube video, or any form. It doesn't matter. It's all depends upon you, because it will not only help you to boost up your profile, but also give you a tremendous chance to learn more in public. Okay. And another important thing is which I learned is your social profile. Okay, you know what? If you want to portray your good view or your professional profile view to other, so you should have a professional profile for this. Okay, because no one comes to you personally and asks you about your interest, but your profile talks to other many times a day. Okay, so your first impression is always your professional profile or your social profile. So take care of your social profile. Well, Cloud Native Islamabad guided me very well how to build my professional profile. So this is all about what I learned from Cloud Native Islamabad, and this is all about the starter of my journey, how I started my 100 days of Kubernetes. Okay. When I started my 100 days of Kubernetes, I came across a word of Kubernetes. So, and I came across a definition of Kubernetes, but at that time, because I don't have any knowledge about Kubernetes and all this stuff, I was so confused about it, because I never ever heard about Kubernetes. So, but what I learned when I go to Kubernetes website is Kubernetes is basically an open source system for automating deployment, scaling, and management of containerized application. But then I explored what was before the Kubernetes, and then I came across this term, which is VM, virtual machine. Before my Kubernetes journey, I was already using this system in my machine, but I haven't taken it so seriously. I've never bothered it. But when I jumped to Kubernetes, I was like, okay, this is an important concept. Okay, I have taken it into account seriously, and I started searching about what is virtual machine, and what I came up with. Virtual machines are an abstraction of physical hardware turning one server into many servers. Okay, the hypervisor allows multiple VMs to run on a single machine, and each VM has its own operating system, one or more application, necessary binaries, libraries, that taking up tons of GBs. Yeah, it is. And that's why VM can also be slow to boot. But we don't need all these things in today's age. Okay. Why? Because we have something more exciting and more incredible thing than VM, and that is container. Container are basically an abstraction at the application layer that package code and dependencies together. Okay. So containers are a way of packaging application with all their dependencies, libraries, and configuration files that package artifact is easily shared and moved around the development team and operation team. And it works perfectly on both operation team and on development team. Okay. So after knowing about containers and also knowing about VM, I started learning about what's the difference between container and VM. And what I learned is all the containers have same kernel or share the same kernel of the host operating system. Okay, whereas each VM has its own operating system, as we already saw. Okay, because container don't have its own operating system, so that's why it takes milliseconds to start up. Okay, so that's why its startup time is in milliseconds, where in VM startup time is in minutes, because it has its own operating system, different libraries, binaries, and a lot of other stuff. Okay, because container don't have its own operating system, that's why container are less secure, because provide process level isolation. Again, VM is more secure than containers because it's fully isolated, because kernel is also separate. Okay, every VM has its own kernel. And the last thing which I learned is containers are lightweighted because it provides OS level virtualization, where VM provide hardware level virtualization. That's why VM are most heavy-weighted. Okay, that's why I can say that containers are quickly becoming an industry standard for deployment of software application. Okay, so that's all about container versus VM. And after knowing the concept of container, I came across another awesome, incredible concept, which is Docker. Yeah. Then I started learning about what is Docker, and what I learned is, okay, Docker is one of the most popular container implementation, where we deliver software application in containers, which simplifies the process by packaging everything it takes to run an application. So after knowing about Docker, I was so curious about the importance or the advantages of Docker. And then I realized that there are numerous advantages to using containers to deploy an application. Let's just discuss some advantages. Okay. First of all, isolation. Okay. Every application has its own libraries, so no conflict will arise from different libraries in other applications. Okay. And the next thing is limits on CPU and memory. Application may not hold resources from another application. And the next advantage is portability. Basically, container contains everything. It's need to run an application, and it will never be tied or not tied to an operating system or a cloud provider. Yeah. And the last but not least, lightweighted, because in Docker the kernel is shared and provide OS level virtualization, so making it much smaller and faster than full OS image. So that's all about Docker concept. And yeah, we're up till now we learned about we learn about VM, we learn about containers, we learn about Docker, the numerous advantages of Docker. Now let me move toward another important, not concept, but in another important, another important type idea, okay, which is CNCF. Okay, it's an important topic. Basically, what is CNCF? Kubernetes project is an open source, as we all know. So make it open source by Google in 2014, where everybody can contribute to this project, or everyone can provide feedback and suggestion, and all the world-renowned communities and companies are looking forward to getting their contribution. And everybody investing their time heavily with Kubernetes, and to make things neutral, governing body established for maintaining the Kubernetes project, and that is CNCF. Basically, CNCF is the largest cloud native computing foundation, is the largest open source sub-foundation operated under the Linux Foundation. The mission of CNCF is to create, drive the adoption of a new computing paradigm and cloud native computing. The CNCF is currently working on or hosts a large number of open source projects such like Kubernetes, like Prometheus, and much more. Okay, the dashboard of CNCF displayed the daily status on both the latest release and the latest development version, and the newest release include, for the first time, the Linux Foundation Open Network Automation Platform. And you know what? After exploring all these projects, I make some plans, some future plans for me, and I want to share my future plans with you. Okay, my future plans are to contribute to an open source project under the CNCF umbrella. And here I listed some of the projects where I want to contribute. And first of them is Linkerd. So Linkerd is a service mesh that manages traffic between services. They enable platform teams to add reliability, observability, and security features uniformly across all the services running within a cluster without requiring any code change. And the second one is Crossplane. Crossplane is an open source Kubernetes and add-on that enable platform teams to assemble infrastructure from multiple vendors and expose higher level self-service APIs for application teams to consume without having to write any code. So, and after this, I have a plan for Prometheus. Prometheus is a free software application used to event monitoring and alerting. It records real-time matrices in a time series database built using an HTTP full model with flexible queries and real-time alerting. And last but not least, Knative, my favorite. Knative is an open source community project which adds components for deploying, running, and managing serverless cloud native application to Kubernetes. The serverless cloud computing model can lead to increased developer productivity and reduce operational costs. So I hope I have to put my contribution, at least one of them, but I'm very hopeful that I can contribute to all, because I know some of the awesome members from Linkerd community like Jason. I hope he will help me out in understanding the process of contribution to Linkerd open source project. And from Crossplane community, I know Daniel, and from Prometheus, I know Bart, and from Knative, I know Salaboy. I'm very hopeful that these awesome guys, these awesome community people will help me out in getting my contribution ready for an open source project in CNCF. So that's all about open source projects in CNCF. but I have some other plans, which is KubeCon plans. Yeah, I have KubeCon plans where CFP is open for KubeCon Valencia right now. Hopefully, I will be able to share my 100 days of Kubernetes journey there. I'm looking forward to having a good topic or around cloud native or Kubernetes for my submission of CFP in KubeCon Valencia. If you have any suggestion or recommendation for me, feel free to reach me out on my socials. I really need some suggestions and recommendation from your side. So I'm waiting for your suggestion and recommendation. Okay. So, and after this, I want to wrap up my whole conversation. For this, first of all, I want to thank this. I want to thank you, this group, and especially Shabazda, who reached out to me and gave me this opportunity to speak in front of you. So thank you so much, Shabaz, and thank you this community who allowed me to come and speak in front of you. So I hope I will join you again in the future and be ready for more events in future as well. So thank you so much for your patience. And if you want to share your journey, if you want to share your experience with me, and if you have any recommendation or if you have any feedback from your side, feel free to reach me out on my social and suggest me or share me your story or your cloud native story with me. So that's all from your side. That's all from my side. If you have any question, you can ask me now, or you can ask me on my social handles. So thank you so much.